Okay, guys, here we go with our first written assignment. I am not going to work it out with you. You have this posted. I hope that you will print it or write it off and work through it. For this first written assignment, instead of having you turn it in to me, I am just going to show you what the key would look like. Notice that you need to be sure that you read your instructions carefully. Perform each operation and simplify so there are no quotients. Your goal here is to get no quotients. No quotients, no quotients. And then with number 4, I get to verifying that each equation is an identity. Again, it is an identity. The answer is never no. It's not even yes. I want you to show me how it works as an identity. Okay, work yours. And then come back to the key. For 1, 2, and 3, where you are verifying identities, where you are simplifying so that there's no quotients, this is what this should look like. I give you the result. Notice that number 1 is just 1. I went to sines and cosines. I simplified and I got 1. On number 2, I FOILed. I squared that. And when I square this, I get this perfect square trinomial. And then I look and I say, oh, look here. Sine squared t plus cosine squared t, that is my Pythagorean identity. That's 1. And 1 plus 1 is 2. You can leave your answer here as 2 plus 2 sine t, or you could factor out the 2. Either one is acceptable. For number 3, I multiplied by a well-chosen 1. And my well, I did. But I was finding a common denominator. I got a common denominator of sine alpha minus 1, sine alpha plus 1. So I multiplied in the difference here, I multiplied in the sum there. I got that common denominator, and those are conjugates. When I multiply together conjugate pairs, I get difference of squares. In my numerator, sine alpha minus sine alpha, 1 plus 1 is 2. So I get to this point, recognize that this is my Pythagorean identity, replace it with negative cosine square alpha. I don't want to leave a quotient, so I'm not done. I need to do something about this. The way I'm going to take care of that quotient is to use the reciprocal identity. So I have negative 2 secant square alpha. Number 4, we start with verifying the identity. You're going to work down the left because that's the more complex side. I showed you a couple of different ways to go. This is a Pythagorean identity. It's the same thing as cosecant square beta. Sine square beta plus times cosecant square beta. Well, I can rewrite that as 1 over sine square beta. And when I multiply this together, I get 1. Or I could have said immediately that sine square beta is 1 over cosecant square beta. And this binomial is cosecant square beta. And when I multiply that together, that's 1. Or I could have rewritten it as sine beta, cosine beta, and factored those out. All right, let's look at the back. Number 5, I have 2 ways to go on number 5. The first way, I'm working down the left. Secant to the 4th x, I can factor out a common factor of secant square. So when I factor out secant square, I have secant square minus 1 left. Secant square x is the same thing as tangent square x plus 1 based on that Pythagorean identity. And this right here, secant square x is tangent square x plus 1. And then I already have that minus 1. So plus 1 minus 1 adds to 0. So I've got tangent square x plus 1 times tangent square x. When I distribute that through, I get my tangent 4th x plus tangent square x, and I have verified. Another way to go. Another way to go would be to go ahead and factor out that secant square on the left, and then recognize that secant square x minus 1 is tangent square x, and then simplify the right side to that same point. On the right side, I can factor out a tangent square x, and tangent square x plus 1 is secant square x. I've got a common expression on both sides. Either approach works. Okay, number 6, I've got arrows going all over the place. So let's kind of work through this. On the right is pretty simple. If I go to sines and cosines, I have cosine over sine, 1 over sine. That multiplied together gives me cosine theta over sine squared theta. That's a simplified expression. If I stop there, I can make the other side match that, making the other side match. I go to terms of sine and cosine. So I rewrite it with just sines and cosines. And then right here, so that my big denominator has a common inner denominator, I multiplied this term by 1, cosine theta over cosine theta. That allowed me to take the numerator of my statement and rewrite it as 1 plus cosine theta over sine theta. And the denominator of my statement, rewrite it as sine theta plus sine theta cosine theta over cosine theta. And then this is just a division problem. I took the reciprocal of the denominator and multiplied. Now at that point, when you take the reciprocal of the denominator and multiply, you can do a couple of different things. You can either keep going down here. I multiply things together, distribute the denominator, recognize that this factors out, this cancels, and then I have this simplified expression. Or I could go from this step over here and recognize that if I factor out sine theta in the denominator, I can go ahead and cancel there. And I have 1 over sine theta, which is cosecant theta, times cotangent theta, which is my original right side of my identity. So I didn't have to simplify this on the left. There's a couple of approaches to get to the same place.